Welcome to the world of AP statistics. By the end of this scene, you will be able to identify the four main pillars of the AP statistics curriculum and understand the foundational role of the statistical problem-solving process. AP statistics is much more than just crunching numbers. It is the science of learning from data. It introduces you to the essential tools for formulating questions, collecting and analyzing data, and interpreting results. The course is built on four major themes. First, exploring data involves looking for patterns and departures from patterns. Second, sampling and experimentation focuses on how we actually plan and conduct a study to yield valid results. Third, probability and simulation provides the mathematical foundation for anticipating what the distribution of data should look like under certain conditions. And finally, statistical inference is where we use our data to make formal conclusions about a larger population with a calculated level of confidence. Because this is a non-calculus-based course, the primary prerequisite is a strong foundation in Algebra 1. You will be using technology, performing investigations, and doing a significant amount of technical writing to explain your findings. We have successfully introduced the course structure and the four pillars you will master throughout the year. Now that we have the big picture, let's focus on the heart of everything we do in this course, the statistical problem-solving process. By the end of this scene, you will be able to describe the 4 steps recommended by the American Statistical Association to investigate a real-world question. Think of statistics as a structured investigation. It always begins with step 1, formulate questions. This means clarifying the problem and phrasing it in a way that data can actually answer. Step 2 is to collect data. Here, we decide on a plan to obtain the data, whether through a survey, an observation, or a controlled experiment. This step is crucial because poor data collection can lead to misleading conclusions. Step 3 is to analyze data. This is where we use graphs and numerical summaries, like the mean or standard deviation, to look for patterns and relationships. Finally, step 4 is to interpret results. We take what we found in the analysis and relate it back to the original question, making sure to account for any uncertainty or variability in the data. For example, if we want to know if a new fertilizer makes plants grow taller, we start by asking, is the average height of plants with this fertilizer significantly higher? Then we grow 2 groups of plants, measure their heights, compare the averages, and finally decide if the difference was big enough to be convincing. Throughout the course, we will return to these 4 steps constantly. We have now covered the framework for how statisticians approach every problem. To really understand why we need statistics, we have to talk about one of the most important concepts in the course, variability. By the end of the scene, you will be able to define variability and explain why it necessitates the use of statistical tools rather than simple arithmetic. Imagine if every person in the world was exactly the same height. If you measured one person, you'd know the height of everyone. In that world, we wouldn't need statistics because there would be no variability. But in the real world, data varies. People have different heights, different test scores, and different reaction times. Variability is the tendency of measurements to differ from one another. Because of this variability, we can't just look at 1 or 2 data points and know the whole story. We need statistical tools to help us distinguish between natural variability and a significant effect. Suppose a new medicine has a slightly higher recovery rate than an old one. Is that 5% difference just due to chance variability, meaning we just happened to pick a luckier group of patients? Or does the medicine actually work better? Statistics gives us the language and the math to answer that question. It helps us find the signal within the noise of variability. We have now established that variability is the reason statistics exists. Understanding how to measure and account for this variation is what the rest of this course is all about.